Welcome and thank you for joining us today for Best Practices for Building Scalable Visibility Architectures. My name is Raleigh Gould and I'll be your moderator for today's event. Our featured speakers are Jim Frey, VP of Research at Enterprise Management Associates, and Scott Register, Senior Director, Product Management at Ixia. Jim has over 25 years of experience in the computing industry, developing, deploying, managing, and marketing software and hardware products, with the last 20 of those years spent in network management, straddling both enterprise and service provider sectors. Scott has more than 15 years of experience leading product management operations for global technology companies. Scott led product management at Breaking Point Systems prior to its acquisition by Ixia. Other past experience includes leading product lines for Blue Coat, Permeo, and Checkpoint Software. And before I hand things over to our featured speakers, I did want today's audience to know that Jim and Scott will be taking your questions at the conclusion of today's event. Do, however, feel free to log those at any time throughout the course of the presentation by using the Q&A functionality. Also, today's event is being recorded and you will be receiving a follow-up email from Enterprise Management Associates that will include the on-demand playback as well as a white paper on today's topic. So please be sure to look for that email and access those resources. And now I'd like to go ahead and turn things over to our featured speaker, Jim Frey.
Thank you, Raleigh, and welcome everyone. Today I think we have a very important topic to cover, and hopefully it will be interesting to everyone. We've got the topic for today is visibility architectures. We want to talk about what we mean by those. So here's what we're going to cover today. We're going to define that and talk a little bit about why the market is moving towards these, why folks are finding this is a very essential approach to management and operations. Then we're going to talk through some research that EMA conducted last fall, some of the findings from that research around best practices and what sort of decision points you have when you decide to try to embrace this kind of approach. We are sponsored by folks from Ixia who offer solutions in this area, and Scott will be adding some color to the conversation regarding the experiences he's had in designing solutions and working with customers to solve their challenges in this area. And then, of course, we'll wrap up and we'll do our Q&A, so please do log any questions you have on the Q&A tab as we go throughout. So let's get started here. First, we want to give some definitions about what we mean by visibility architecture. And here's what we're really looking at. This has to do with the use of packet inspection technologies for both network and application performance monitoring and troubleshooting and analysis, as well as security management and monitoring. There are lots of different technologies for these areas that require a stream of packets in order to do their job. And the visibility architecture is intended to be a systemic approach that actually lets you do this effectively. There's a couple things to think about when we think about this. What we're really trying to do is make this, we use the architecture word importantly, not lightly. We want this to be permanent. We want this to be a new substrate that is put in place in order to really truly optimize and make as resilient as possible and as efficient as possible these monitoring and management functions. So that's the objective of visibility architecture: permanent, reliable, adaptable. It needs to be able to also be scalable. That's part of the title of our event today. It also needs to be have the ability to be flexible and sustainable, meaning that this is not something you're going to set up for a few weeks and then tear it down. No, we're talking about something that's long-term and permanent. So it has to be sustainable, it has to be adaptable to changing needs, and it has to be able to grow with the needs of the business. So those are the kind of attributes. I mean, these are architectural attributes. They're the things you would say around any part of architecture planning that you do in your infrastructure. So let's put this in pictures so we can get a better grip of specifically the pieces of a visibility architecture that we're going to talk about today. So we start with a network, because this is about finding and harvesting and working with packets that we're going to be analyzing for security and network and application monitoring purposes. So you start with your network, and you've got a number of different packet analysis and monitoring systems out there. There's lots of these. We're going to talk about more specifics about the different choices there and types as we go through the presentation today. But one of the key things is there are lots of them, and their number is growing. So you have to figure out a way to get the packets from the network up to this layer. Well, historically and originally, the way this was done was to just simply use taps, which are simple layer 1 devices that will sit in line and peel off a copy of the packets, forward those over to your monitoring tools. Or you could use the intrinsic functions within network switches that it's called port mirroring, or more commonly known as span, and actually connect those devices, those monitoring devices, to a switch port directly. And the switch takes care of generating the copy of the traffic and shipping it out that in what is essentially a diagnostic port. This is effective. It works well, but there's some problems with it. And the big problems are it doesn't scale well. There are technical issues we're going to talk about too that render this approach marginal to unacceptable over time pretty quickly, actually, as soon as you start getting into any size of deployment. But the need really was to find a better answer to this so that we're not looking at one-to-one connections and we don't have to connect each individual tool to each individual location. What we're really talking about in a visibility architecture is adding another layer. And this layer is a controller layer. I'm labeling it here, and what EMA calls these components as network visibility controllers. We're going to be talking a lot about those today. They're also known commonly in the industry as network packet brokers, and so we'll be using those two terms interchangeably. But essentially what that layer does, and what makes this an architecture, is it ends up being a platform that helps you to manage those streams of packets so that you can more effectively and more reliably use them, harvest them, and distribute them, and use them for all the monitoring and management purposes you need. So that's what we mean by visibility architecture. Now, I want to point out one other thing before I move on. I've got little dots going in many directions here, and the point is that this can be replicated and stamped out on a multiple step-by-step basis. So you can have lots of taps, lots of spans, lots of infrastructure, lots of monitoring systems, and lots of network visibility controllers. So it is designed to be and intended to be a scalable, replicable type of approach. So what I want to talk about before we get into the core drivers is just make sure people understand what we're talking about for this layer, this new important layer, which is these network visibility controller or network packet brokers. It really is the heart of the architecture. Without these, you just have lots of taps and spans. But for an architecture to be there, you need these platforms. It really is important to understand that the role that these platforms play, is to go beyond those traditional tactical approaches to do one-to-many, many-to-one, and many-to-many connections. And this is where they really add their value, to be able to draw packet streams from multiple sources and distribute them to multiple consumers. Along the way, there are some really advanced features that have been developed for this layer to make them more effective and more efficient. We're going to talk about those in detail later. But just think for now about the fact that there's filtering that can be done, there's header stripping, there's decryption, there's timestamping, there's port stamping, a bunch of different things you can do with the incoming port streams, packet streams, so that the downstream analysis tools don't have to do as much work. So they can offload some of the basic features required at the analysis level, so the analysis tools can simply digest the results. And really importantly, and you're going to hear this a bunch of times today, one of the things they can do is load balance those tools. And that pays off dividends in a number of areas. And like I said, we're going to go through that in more detail. One last point here, there are other aliases out there. If you go looking for these solutions and you look at some of the suppliers of these solutions, you'll hear them called a number of things. NPB, Network Packet Broker, is probably the most common term in the industry now. You're going to hear NVC a lot today because the research that I did and published last fall included the term NVC to describe these platforms. But there's others. Here's some other examples. Network monitoring switches, distributed filter trap, there's others out there. So be aware that there are other names that you might run across when you're looking at products or solutions of this type. All right, so I want to talk about three key drivers that EMA sees as driving the need and creating the need for these kind of architectures. And the first one is just the fact that networks grow faster. And this is hopefully not a surprise to anyone. Everyone's been watching this happen for quite some time and will continue to grow. And as soon as we finish moving to one speed platform, well, then the next one comes along. So the interesting thing here's some of the data that we gathered on this last fall and published. And it's really quite interesting that most of the industry is now at 10 gig in the core data center networks, but quite a few have moved to 40, a small number at 100. But most interesting here is the fact that there's a lot of plans to look at those higher speed type technologies in the next year or so. Now, we might come back a year from now and plans may not turn into reality necessarily, but the fact that there's this much attention being paid is worthy of note, especially when it comes to this visibility architecture, because in reality, the big problem this creates is that those monitoring tools aren't necessarily ready to keep pace with the speed of the networks. Most monitoring tools today have made the transition, packet-based monitoring tools, have made the transition to 10 gig pretty successfully. Most of them have. A few have fully vetted 40 gig line rate type capabilities, but only a few. Absolutely none of the monitoring tools are fully vetted at 100 gig at this point in time. So you have to have some means to get packet streams off a 100 gig link and send them to a tool that may only be 10 gig rated. And in fact, many are still only 1 gig rated. This is a role that the visibility architecture can play for you. And it's one of the reasons we see deployments of these things. Another one is the number of tools. I mentioned this earlier. There is a lot of different types of tools out there that analyze packets in order to deliver their value. So again, we asked how many tools are attached to these kind of platforms in this recent research, and it's a pretty big number. If you add up the percentages here, it comes out between 3 and 4 different types of these technologies deployed in the average shop. So that's a bunch, and that's really important also, by the way, when it comes to the choices you make about how you collect and distribute packets, because there is this technical architectural limitation of span, for instance, whereby a network switch can typically only support 2 span sessions. So the old tactical approach of using span as your source directly to the tools runs out of steam as soon as you have more than 2 tools. And this is a well-known problem, and it's something that's been around for a while, but it starts to become one of the issues that's driving the use of a visibility architecture to collect that data from a span port one time into an NVC or NPB and then distribute that across multiple analyzers. Solves that problem quickly. One other thing I want to point out about this particular research finding here is that while traditionally we have a number of tools that most shops have been adopting, the interesting thing to me is the plans in the next 12 months are across the board quite similar. Between a quarter and a third of everybody is looking at more tools of each type. And if you add that up, on average, 2 types of tools are going to be either planned for further deployment or deployed for the first time. So while we're looking now at an average of 3 to 4 of these types of tools per shop, in a year we might be more north of 5 and even north of 4 and looking at 4 to 5. So again, further fuel for the need for being able to have this layer to replace the old dedicated link approach that I mentioned a couple of slides back. Lastly, I want to talk about a special use case that's starting to get a lot of attention, and we're again going to talk in more detail about this today. But this is an inline use case. Most times historically, visibility architectures have been used out of band, meaning they're passively collecting copies of packets for analysis. But there are, and you'll notice on my tools list, there were some active technologies. There was things like DLP and IPS. And these technologies are getting more and more attention because folks need these kind of intervention enforcement technologies inline in the network. The problem with them has been concerns about their performance and their resilience. When you put a box in line like this, you don't want it to create any performance problems. You don't want it to cause any loss of packets unless they're the packets that are supposed to be blocked. And there's some concerns about the throughput as well as the resilience of these platforms. So one of the key opportunities here, and what we hear a lot of people doing, is using this network visibility layer, the network visibility controllers / NPBs, because they can do load balancing and they're very highly efficient. They can be put in place inline and take care of resolving the performance and resilience issues. And this becomes another driving complementary use case for visibility architectures. So before we go into the best practices, I want to give Scott Register a chance to chime in, give a little bit of his background. So as we talk about best practices, and Scott and I will be going back and forth about what we're hearing and what we've been finding. Hopefully you'll have some understanding now of what his context and where he comes from from his viewpoint. Scott.
Yes. Hi, Jim. Thanks, everyone, for joining us today. And, Jim, thank you for that great introduction. Yeah, Ixia is a pretty key networking company. It may be one that many of you actually haven't heard of because our background is actually in the sort of test space, meaning equipment manufacturers on the wireline side, the mobile side, people like that, and service providers use our equipment historically to test their devices and things like that prior to deployment. Ixia has recently grown out of that test space and into the production network side. So with the acquisition of companies you actually may have heard of, Inui Systems and NetOptics, we now have a complete line of network visibility solutions. And so this is what our customers use in their post-production networks to understand what's going on, to maintain security, and maintain compliance, maintain visibility and troubleshooting and things like that, even as the networks get more complicated and more sophisticated. One of the advantages that this kind of broad sweep of technologies that we have is that we're not surprised by things that happen in the networking space, right? By the time 100 gig networking is deployed in a data center, our equipment has been testing it for a good 5 years, right? So all of those equipment vendors who sell and manufacture 100 gig switches or virtualization components or things like that have used Ixia gear as they develop and test that. So we get this great sort of preview into what's coming out into the market, so that by the time it's released into the wild, we already have systems in place that can cope with it. One note, Jim, I really liked your diagram earlier that showed sort of what the basic components, the visibility architecture. And I do want to stress that one of the big drivers or big changes we see there is the move toward virtualization at all layers of that, right? Whether it's the kind of tap and networking side and even the tool side as well. This is another place where Ixia is kind of leading the charge on the test side. So as those networks evolve to virtualize both the server and the networking capabilities, we're there. We've seen those pieces. Thank you.
Great. Thanks, Scott. Yep, we are going to talk more about virtualization because that is an important part. I didn't put it on my architecture slide there because it was just another confusing virtual sort of thing to try to represent, but very, very real, and we are going to talk about that in this next section here. But first, we're going to talk about where you deploy these things as our first best practice topic. Topologically speaking, where are these devices being deployed? Certainly, we know we have tap and span. We're going to talk about that next. But where do you put them? So this is kind of interesting. We talk to folks and find out where have you been locating your NPBs or NVCs. And you can see historically most people are putting them in the core network and the data centers. In general, it happens to be most advantageous to put them wherever you are going to see concentration of activity, concentration of traffic, where you get more bang for your buck. So you're not going to necessarily put them right out at every leaf node. That wouldn't make sense. But in the core, top of rack, end of row, also data center type locations at the edge of the data center. Even more commonly now in the campuses, remote campuses and remote sites. So any place where you're going to be able to see as much as possible from the location that you're going to be gathering from. Interesting, I think, here is that, historically what this research showed was that most people do absolutely start with the data center core. Pretty even interest across the board in deploying these in the next year out in other parts of the network. And in fact, growing interest in using these kind of technologies out at remote sites. So I think that's kind of interesting. So the answer is you might have to pick what makes most sense to you, but clearly historically it's been in and around the data center first and then moving out into the network from there.
That's right, Jim.
Scott,
we're seeing a pretty broad range now. There are some environments where everything is in one spot. I mean, the kind of service provider and large hosting centers are very typical of that, or just the way that the data center physically is built. Sort of everything, all the links that need to be monitored, et cetera, are fairly well centralized, or there's kind of plenty of interconnect fabric available to backhaul everything to one spot. And in most cases, the tools themselves, whether they're security or performance monitoring tools, are centralized for management and price reasons into kind of one central tool farm. But in mirroring the way that many people are rolling out, their data centers, we're also seeing a growing number of top-of-rack or end-of-row or even campus-wide deployments for the visibility solution. So that the fact that, if you have the right architecture in place, you can separate your tool deployment from your visibility architecture, meaning you can centralize those tools and still maintain distributed visibility. That's a pretty big driver, and that's something that we spend a lot of time thinking about.
Absolutely. Good points. Good points, definitely. Good. So there's some sense for where these things get deployed. What we want to talk about next is the use of span and tap. That came in earlier when I talked about the overall architecture. There's some interesting choice points around this, but we're going to start by asking a question of the audience around this topic. Raleigh, can you launch our question for us?
Yes, I sure can. Everyone should hopefully see the poll question now. It is, if you have network or security monitoring tools that require span ports or tap connections, do you, please select one of the following options: plan to expand use of span ports, plan to expand use of taps, plan to add both more span ports and taps, or your final option is have no plans to add more span ports or taps. The poll question will be open for about 20 or 30 seconds, so we appreciate you taking time to fill it out. While you're doing that, I did want to once again remind the audience that Jim and Scott will be dedicating the last 10 or 15 minutes to answering your questions, so I do encourage you to log those using the Q&A functionality. Also, I had also mentioned that you will be receiving a follow-up email from EMA tomorrow. It will include not only the playback of today's webinar, but also EMA and Ixia have recently completed a white paper on this topic, and that is how you can get that white paper. I also encourage you to visit Ixia's website. You can access it there as well. So the poll is now closed. Thanks again for taking that, and I'm going to go ahead and turn it back to you, Jim.
Okay, thanks, Raleigh. And thanks, everyone, for putting info in. Looks like we had about a small number interested in or planning to use more span, a few more, quite a bit more using taps. Biggest response is combination. We're going to use more of both. And then there's a few folks who don't have any plans right now, and that's not terribly unusual either. I think it actually lines up remarkably well, these results, with what the research showed us when we asked this question last fall. In fact, this is something that EMA has been tracking over a period of time. Originally in 2009, we did some research on this question with Anui, that's now part of Ixia, and we asked this again here in 2013 to see how things had changed. And it's been quite a remarkable shift. I think the results we got from our poll here actually match quite well with the 2013 numbers, saying that there is some use of span, a lot of mix, but it's definitely tilting more now these days to use of tap. There's a variety of reasons for that. It really comes down to some technical limitations and challenges with using span, especially when you talk about scaling and you talk about keeping up with heavily loaded environments. And Scott's going to talk more about that in a minute, but I just want to point out here that this is really a quite remarkable trend. Here we had 2009, a few years ago, we had 1 in 5 shops was using all span. And if you look at those top two bars combined, I would say, 2 in 5 were using predominantly span as approach. Nobody's doing that anymore. For the most part, now it's a mix, and you're starting to see an increase in the number that are using purely tap. And the big reason for this primarily is that with taps, you're going to get and see everything. With spans, you don't necessarily know you're going to get and see everything. And I think that's probably a good point to hand over to Scott to let him talk about what Ixia has been seeing in specific in that regard.
Yeah, that's right. And some of the drivers away from span and toward tap, as you mentioned, there's CPU impact typically on the switch or other limitations which just limit the amount of data that you can get out of the switch, the number of different segments or VLANs that you can monitor, the number of packets that you can pull out, and things like that. There's another problem with using spans, and And I will say most people sort of get started this way. It's not an uncommon thing, but over time we see them migrate away from spans to more tap deployment, which is exactly what we saw in the graphs that you showed. One of the challenges, though, with using span ports is sort of data integrity. As we discussed earlier, you can lose packets, but you can also see a lot of duplicate packets. In fact, in some environments, we see up to 50% duplication of data coming out of the span ports on a switch. And there are a couple of reasons for this. One is typically filters are set up sort of per VLAN, and you may get a packet when it both enters and exits that VLAN. So, when you look at sort of the input traffic to your tools, you'll see the same packet multiple times. This causes a couple of problems. One is just the sheer amount of data that's going to your monitoring tool is increased by 50% or so, right? And typically these tools have some limitation on how much they can process, so you're going to overwhelm that tool without adding any value. Another problem is, especially if you're doing network performance monitoring, you may be very interested in understanding if you get duplicate packets, maybe you're getting retransmissions or something like that. If you're sending duplicated packets to the tool that aren't retransmissions, you're going to confuse it, right? So that tool is going to think that there's a problem on the network of duplicate packets when really there's not. So one of the things that a visibility solution will do for you is remove those duplicated packets. So if you are accessing span ports, physical or virtual, can remove those duplicate packets from the flow so that your tools only get one copy of the data.
Yeah, very good, very good. Definitely something, I think this is one of the things that drives people away from span. The other is, and one of the things I've heard in some of my conversations is concerns about the potential for a span to get overloaded. If you've got a fairly busy switch and you've got a lot of switch ports in it, your outbound span port is only as fast as the fastest link speed you've got, and yet the switch as a whole is carrying a whole lot more traffic than that. So it is possible to saturate a span port and then draw packets, and then you won't even see the things you need to see in your analysis layer. So technical limitations, again, I think, Scott, you had it right. Most people start here because it's the quickest and easiest, but over time they migrate away towards using taps as a way to be more complete and reliable. Great. So the next topic we want to talk about is of that inline versus out-of-band deployment model. And here I think the real key thing is it's really quite interesting the number of folks that we talk to who are deploying NPBs, NVCs, and they're starting to use these in an inline mode. The primary use case really is around security. It's around using NVCs as a way to load balance active security technologies. And I was really surprised in our research the number of shops that actually were really looking at this heavily. Not only had 40% of the folks we talked to already done this, but another 50% were planning to do so. So that's what I'm going to feel comfortable as describing as an overwhelming majority. So if you're going to do this, the keys to this are taking advantage of that load balancing capabilities of the MVC or MPB, as well as you also need bypass technology. So bypass allows you to take a portion of traffic out of a traffic stream, run it through something else, and then reinsert it. So you have to have both of those capabilities, and that's important to understand too as part of the way that you actually put into effect an inline type of a deployment. Scott, do you have some more you can share about that?
Yeah, absolutely. I think the reasons for deployment of inline security are probably clear to everyone on this call, right? We've certainly seen things like trends away from intrusion detection to intrusion prevention because you want to stop the problem, not just know that you have it. But when you deploy a security device inline, it's more than just a bump on a wire, right? And so you want to make sure that that security device, whether it's a firewall or a DLP system that you're using to monitor outbound email or UTM or maybe even an SSL intercept device, you want to make sure that that's not going to harm your network. Now, these are typically at some level software solutions, even if they're running on some specialized hardware, and so they can go down, right? And so the worst thing that can happen is you have maybe there's an attack, maybe there's a glitch in your system, something like that, and suddenly your network goes offline because the security device has failed. So So one of the considerations when you're deploying an inline security solution is if you can integrate that into your visibility architecture and integrate things like bypass solutions, then, which we'll talk about, then you can keep your network up, right? You can keep it from failing because we can do things like detect, oh, this device is down. We want to keep the network flowing, so we'll just take it out of circuit. Or maybe you need to load balance across a number of IPSs or firewalls or whatever to make sure that they can scale in line with your growing network demands.
Great, thanks, Scott. And Scott, you had mentioned earlier the fact that we need to deal with virtualization. We absolutely do. Virtualized environments create a new interesting challenge to visibility, and that, in particular, there is network traffic and therefore packets that are transiting between systems, virtual systems in this case, that may never cross a physical wire. And so it's a new set of challenges to figure out how do you track and recognize, if you want to be able to monitor and troubleshoot a performance issue or monitor security, compliance, and yet that traffic never goes on a wire that you can tap. So there's a variety of techniques for gaining access and reestablishing access into virtualized environments. And actually, there's sort of two mixed versions of that here that I'm showing in the results of our research. The first has to do just simply with hypervisors and the use of virtual computing, which carry, as part of their architectures, virtual switches and virtual switching either within the hypervisor and increasingly distributed virtual switching that actually does connect VMs across multiple hypervisors. Well, if it's between multiple hypervisors, it's going to go across a physical wire. So that's helpful. Unless it's in the cloud where you don't have access, that's another set of issues. Bottom line is you need some alternative approaches that give you a more reliable ability to reach in and grab a copy of packets for packet-based monitoring. So the kind of techniques that have been used to date in the marketplace are listed here, the most common ones, and this is the kind of usage that we saw in the folks that we talked to. The first one is a natural reaction by the tools vendors. The tools vendors realized they needed to be able to accommodate this, and their first answer was to basically create a software version of their analysis tool so it could be dropped onto a VM and passively listen to the vSwitch. This is great. It works. The challenge comes with figuring out how you are now going to use up a VM, or because, as we talked about earlier, you might have 3 or 4 different types of packet-based monitoring you're doing. You might need to try to accommodate 3 or 4 VMs in every hypervisor that you have out there, and that becomes very difficult to scale. So it works on a point basis, on a tactical basis, but it's not a good answer from a scalability perspective. A lot of people are using it, though, on a tactical basis, and they're using it because it was one of the first approaches really truly introduced here. The middle two are, I think, gaining more acceptance and are more promising. And the top one is using now, the virtual switches out there now have span functions. They didn't initially, they do now. And so that gives you a way to get to the packet streams. The other is the use of virtual taps. Now, virtual taps can either exist as a virtual appliance in a VM, or they can actually be software that is connected at the hypervisor layer. Either way, what they do is grab a copy of packets and ship it out the physical network interface card on the hypervisor host, so that they can be picked up and added into a visibility architecture. So both of those, very viable approaches to reestablishing visibility into the virtualized environments. The last one on the list here I'm going to mention is this header stripping for overlay. This is another type of virtualized situation where you've got virtual network overlays. And virtual network overlays are technologies that are created to try to abstract connectivity away from the physical infrastructure. The common examples product-wise you'll see of this out there in the world are things like the NSX from VMware, Alcatel's Nuage. There are others, Midocores, Midonet, there's others, and I apologize if anyone's on the phone and knows of others and I'm not mentioning them, but I don't want to go through that all today. But bottom line is the way that these solutions work in most cases is they create an encapsulation layer where they encapsulate traffic to move it across the network. And so what you typically see is traffic from point A to point B. But in reality, that's a pipe. It's an encapsulated pipe that is really delivering point C to point D, but part of the traffic, part of the path of that traffic is point A to point B. So being able to strip away those encapsulations and understanding the true source and destination is an important part of maintaining proper and complete visibility in these virtualized environments. So last point on that, it only shows about 34% of folks who are using that sort of approach. That actually reflects the general current level of adoption of that technology in the market as a whole. It's still relatively early in the marketplace adoption. So the fact that it's not more heavily used is more related to the fact that it's a new technology than it is a less popular technology. So the bottom line here, depending on how you have deployed, what type of virtualization you have in place, how you have deployed the infrastructure, you might need to pick a combination of these techniques in order to maintain visibility. Scott, I think you have some thoughts to share on this one as well.
Absolutely. We mentioned earlier some of the problems with using span ports on switches, right? And it's important to understand that many of those challenges, whether it's performance or data duplication, things like that, carry over into the virtual world. So when you're trying to pull data out of a virtual switch, certainly, it's running on the same hardware as your processing, right, as all your application processing. And so there will be performance limitations. In many cases, the implementation is not very either CPU efficient or very secure. In many cases, if you're pulling information out of a virtual switch, this is actually accomplished by putting that switch into promiscuous mode, which poses tremendous kind of CPU overhead on that switch processing because it has to look at every single packet from everywhere. There are also security challenges with having that virtual switch kind of see and replicate all traffic. And then there's the added problem within the virtual space, as you pointed out on the last slide, getting data out of the system, right? Does it take a physical NIC, or can you multiplex it on top of other traffic? Is it all carried over one physical link? Do you encapsulate it, and then at the other end, you have to take that data out. So there are certainly some very specific challenges with getting data out of a virtual switch, and then there are some of those kind of common span port problems that carry over into the virtual world. That's why we really think that taking a virtual tap approach, for the exact same reasons we saw in the physical world, getting data out of virtualized systems via a virtual tap rather than a virtual span port has a lot of advantages.
Great, yeah, absolutely. And it'll be interesting to watch as we go forward how the adoption of these various different techniques progresses. All right, I want to move on to our last best practice area, and this is thinking about which features within these NVC NPB platforms really are going to be the most helpful to you as you deploy visibility architecture. So here's, again, some additional research that we did around this. And this is a list of capabilities or features that you will commonly find with most of these solutions in the marketplace. And it was the intent here was to understand, for those folks who had deployed them, what were they getting the most value out of? What were they seeing as being an important feature of this? So before I go into the descriptions, I want to make sure everyone understands the scale of this particular little chart here. The way we asked this question was, please rank it 1, 2, or 3. Is this critical, helpful, or not important? And so the first thing you recognize and notice is that for the most part, all of these were considered at least helpful or more than helpful. None of these were really, I was expecting to see a few of these drop away as really not being important, but in reality, folks like to have all of these different options in front of them. With that being said, the ones that sort of rose to the top were the filtering and load balancing capabilities. So we've talked about load balancing a number of times here today, and that ends up being a really important feature within these products. It is something that you can't do without an NVC NPB very effectively. The filtering capabilities also, now we had split them in two forms here. Let me just give a quick definition of what I mean by these. Inbound filtering means that as you bring data into the NPB for the first time, you strip out certain things so that no downstream tools can see it. The best example here is critical or sensitive information like credit card data or patient data. Or transaction data, more the payload type of things that might be in the packet streams. And that regulations and governance might require you to hide from all potential analysis viewpoints. More common in use, though, really frankly, is the outbound filtering, and what most people think of as filtering is the outbound side, which is that after you have the packets in, you get to select and tune that packet stream on a tool-by-tool basis. So a good example there would be, let's say I have voice over IP in the mix. I only want to shoot the voice over IP traffic out of the total aggregate traffic I see to my VoIP analyzer. But my IDS, for instance, I want to send everything there because there could be threat signatures in any of the packet streams, including the VoIP traffic. So outbound filtering is basically selecting and tuning on a tool-by-tool consumer basis. Inbound filtering is more of the regulatory and a little bit more of the heavy-handed approach of saying, okay, there's certain things I don't want anybody to see. The rest of the choices here, you can see various different levels of interest. I'm not going to go through all of them in detail, but if anyone has any questions about what they are, we can certainly take that during Q&A. What I do want to move on to here, though, is the fact that one of the other interesting things we found is there was a difference in the responses based on the type of organization you were in. And this represents the fact that there are certain objectives that are different if you're in a financial institution, for instance, versus a manufacturing group or a healthcare group. So these three subgroups, financials, manufacturing, and healthcare, were each roughly 10% of the participants in our study. And they showed a little bit different mix. Now, most of them are calling out load balancing and filtering, but then there's a few that are kind of unique. For instance, financials likes and sees value in timestamping. Timestamping is something that is important as part of deep and detailed latency analysis, especially becomes critical for trading environments, trading floors, where there's an extreme sensitivity to any sort of latency or sequencing of packets and transactions. So that becomes really important there. Manufacturing was really like to deduplication and a little bit on the tunneling side of things. Tunneling is something you use to take a copy of packets and then send that to maybe another remote location for deeper analysis, and you use a tunneling technique to do that. So that might reflect more interest there because of the fact that manufacturing sometimes is a more geographically distributed organization and may have not have all the tools available in all places. They try to keep costs down per site. So when you do need that on occasion for a troubleshooting scenario, you set up and tunnel traffic back to to a central location where you can do the deeper analysis. Yeah, healthcare has their own. Yes.
Hey, sorry. I'm sorry. One thing I wanted to throw in here, which I find interesting, this does a great job, I think, of capturing the kind of packet filtering and aggregation and manipulation requirements. What I find is really interesting is probably half of the requests that we get from customers aren't just around the what do you do with a packet. There's another set of requirements behind this around things like management, role-based access control, integration with data center automation systems, things like that, which are very important for kind of the full functioning of a system and maintaining compliance and things like that, but don't directly relate to the kind of packet handling capabilities. So I think these things are spot on. I just think it's interesting to note that half of the requirements, I think, in this space aren't directly tied to how you handle a particular packet.
Yeah, very excellent point. Thanks, Scott. In fact, Scott, why don't we go ahead and I'd like to hand it over to you to talk a little bit more about, on a broader basis, what Ixia's approach is to visibility architectures.
Yeah, thanks. We've developed this visibility architecture, and what this really gives us gives us a platform for deploying visibility throughout a network and for engineering it into the network from day one. And the reason to do this is we want to help you avoid blind spots. And so if you deploy just a sort of series of point solutions, I've got this virtual thing over here, so I'm going to deploy one system there, and I need taps here, and I need a packet broker over in this spot, it's very hard to know for certain that you're not missing critical data, or it's very easy to find yourself in a situation where you've got some application and you're trying to understand why it's not meeting your requirements, why the user experience isn't good, and you you don't have visibility into that spot. You can't reach out and find it. Your tools just don't support it because they can't go and find that. So we've built this multi-tiered architecture. We talked earlier about things like span and tap ports. So we have a complete solution of everything from copper to optical bypass taps. We also have a range of inline solutions, if you're deploying security solutions, as well as certainly the industry's broadest offering of virtual taps. So we can reach into physical or virtual world, pull out the data that you need, and get it to the next tier in the architecture, which is the packet brokers, right? And in some cases, especially in the performance monitoring and troubleshooting cases, these are out of band. And then in more security-oriented deployments, they're inline, right? And we talked about these earlier. But this is the tier where you decide, what traffic gets handled in what way, who can access it, what kind of special processing do you need to do. Maybe you have encapsulated traffic and you need to remove VLAN tags or some other information like that because your tools can't deal with that. They can't deal with the lower layer information. Maybe you need to color the traffic in some way, such as applying timestamps. Or if you're, for cost reasons, aggregating lots of input links into a single tool, it might be important to understand which input port traffic came in on. So we can do things like apply VLAN tags or other tags to that packet on the way to the tool, so that when you go back and look at something later, oh, this is exactly where in my network a certain thing happened. Now, to really add value, on top of the switching and the sort of physical access pieces, we're also developing a level of session and application-aware solutions. So this takes you from just sort of moving packets around to really being able to understand and visualize and manipulate your traffic at the application level and at the session level. This is somewhere where being Ixia is a real advantage, because we're not just coming at this, sort of as a switch vendor who's trying to add intelligence in. We've got this broad spectrum of technologies inside the company. We know all about applications. We know about security because we have these very, very robust kind of test environments and platforms that our customers use to validate security and application handling. So we know what all these applications look like. We have knowledge in like the SDN space. We actually chair the ONF Interoperability Forum, so we're very, very deep into SDN. So we can integrate that kind of knowledge of the environment from low-layer protocol stuff up to application layer, so that when we're handing tools to information, when we're handing information to the tools, we can sort of correlate that and apply intelligence around it. We can also give visibility directly to the end user. So you want to know, are things good or bad in my network? And if they're bad, where should I go to find out more? We sit at that spot in the network. We see everything going on, and we can kind of give you a pointer to where to go next. And of course, if you have to manage all this stuff as a series of point solutions, then it becomes a time sink, right? And that's not what anyone wants. So we've built a management layer that sort of encompasses all of these pieces, everything from the manageable kind of smart taps, just doing SNMP polling and understanding performance of those, through configuration, through multi-device management and managing distributed clusters and distributed visibility solutions, all from a single pane of glass, right? So you can come in the morning, sit in one spot, understand your network health. If you have to make changes, you can do that all from one place and really understand what's going on. And with this combination, these tiers that sort of collect all the data that you need, but then abstract, is this physical, is this virtual, did this come from this kind of device or this one? That doesn't matter. It lets you focus on the problem. And by deploying this through your network and sort of thinking about it from day one, you can be sure that when you're looking at your monitoring applications or you're deploying your security devices, that there are no blind spots, right? You've left no sort of gaps that aren't covered in that network because we have this very comprehensive solution. So that's our new visibility architecture. It's really, when we take the sort of combined products of Anui systems and NetOptics and roll all of those things in, it rounds out the portfolio, and we have tremendous engineering that we're applying to integrate those, integrate the management applications, add more sort of application-aware intelligence to solve new classes of problems for our customers. So, yeah, we're pretty excited about that. Thank you.
Thanks, Scott. Excellent summary there. Why don't we move right towards wrap-up and Q&A now, since we're getting close to the end of the hour. So a couple key takeaways, hopefully, you picked up during this talk today. We really see, from an EMA perspective, some both tactical as well as strategic advantages in terms of the way the visibility architectures can help you with optimizing the effectiveness and the resilience of your security and performance monitoring architectures, and tools and solutions that you make your investments in around packet-based inspection for those purposes. From a deployments perspective, pretty clear best practice had to do with starting in the core and working your way out. That seems to be a pretty good and replicable approach to follow. There is a lot of value in the features in general that can be provided by NPBs. Certainly, it seems load balancing and filtering have been most commonly noted, but your mileage may vary depending on your sector. And I think last and probably most important from an EMA perspective, as we look at the various different solutions that are out there, our recommendation is really look at the scalability of these solutions. Are they ready to keep up with the growth that's going to be happening in your network? Are they going to be able to handle large distributed monitored environments if you have those? What's the flexibility and completeness as well? And the manageability. We didn't spend a lot of time on manageability today, but Scott mentioned it. The bigger of a deployment of a visibility architecture you engage in, the more likely you're going to need effective management tools to keep up with the deployment, the configuration, and the optimization and tuning. So with that, I think we'd like to move forward to Q&A, and I think, Raleigh, do you want to introduce Q&A?
Yes, I do. Thank you, Jim. Before we jump into that, I did once again want to encourage the audience to get this new white paper. It will be part of the email tomorrow that goes out, and you can also access it from Ixia's homepage. So go ahead and do that. So let's go ahead and jump right into the questions. Starting with you, Scott, this audience member wants to know, what is the time length associated with detecting duplicate packets with the tool ports?
It's typically in the hundreds of milliseconds range. So, and there are a few variables there related to things like link speed and packet length. So there are some trade-offs, but it's typically in the between maybe 500 milliseconds and up a little bit from that. We probably have to take it offline to understand exactly in a particular deployment scenario exactly what's the window going to be. But I will point out here there are a couple of different ways to do deduplication. There are both flow-based and packet-based approaches. There are some trade-offs of each. Actually, in-house we have both of those. So there are some which are very efficient in that you can spot the beginning of a flow, say, oh, this looks like another one that's going through, so I don't have to examine every single packet. I can remove that whole thing. And in those cases, sometimes the time window is a little longer. We also have solutions which do it on a packet-by-packet basis. So if you've got two flows and only, they look different. They look similar, but there are only a few like duplicate packets, things like that. We can be very selective about those. That's sometimes more effective for UDP streams and things like that. So the answer is, and with most things, is it depends, and we'd really have to look at kind of what's the best fit for that particular problem.
Great, thank you, Scott. This next question I'll pose to both of you. It is, how hard is it to set up, configure, and maintain a visibility architecture like this? Scott, do you want to get started?
Sure. Well, if it's done, I think if the architecture was built kind of correctly and management of the system, of the infrastructure, was really considered from day one, then it's not too bad. I mean, for instance, we had a customer doing a distributed, I think six switch deployment a few weeks ago, And they had everything up and running in 45 minutes, and single pane of glass, managing the whole system, and had all their all the ingress ports hooked up, and then they just had to sort of tweak the tools. I think the key thing to that is where your visibility architecture provider, how important did they think management was? Because if you come at it again, I think from that sort of, I'm a switch vendor and I'm building a piece of hardware, you may have great performance, you may have good functionality, but when you get into managing multiple devices, managing across physical and virtual environments, things like that, it can be quite difficult if your emphasis has really been on the sort of layer 2-3 packet handling and not on the management infrastructure. Jim, any other comments there?
No, I think you have it largely. Now, most folks, as they build out new infrastructure, know up front that they need to have some visibility, and so the first piece of this is making sure that you deploy taps. The challenge with deploying taps, by the way, is that you are going to have to temporarily break connectivity to insert the tap link, and so you either have to have a maintenance window ready, or you do it when you're building out new, other major infrastructure changes. That's, by the way, one of the appeals of SPAN. You don't have to actually break anything; you just configure it, and away you go. So that's probably the biggest challenge, is making sure that you understand sequencing time-wise, how are you going to make sure that you've got the taps deployed if you're using those. And then the rest of it is, a lot of these solutions have come a long ways in terms of being very quick to deploy and easy to manage in particular, and not just because they're a sponsor, but I will say that the Ixia NPBs are quite good in terms of having very quickly and easy to learn user interface for managing and configuring their platforms. And that cuts down the deployment time significantly.
Yeah, thanks. One other note I'll point out there. There's there's kind of two phases. There's the initial deployment where things like the easy UI are of course like critical, right? But in terms of ongoing operation and time involved, one of the things we've really invested in is rolling out an automation API. So we have a RESTful web API which lets you integrate your visibility architecture into a data center orchestration system. So it's easy to use as the UI may be, and we all love it. We also see a lot of value in being able to plug directly into more automated systems, right? I mean, why is SDN such a big deal? It's not because the switches are cheap. It's because it lets you rapidly provision and deploy new applications, new network services. So our real model is we think that the visibility solution should just automatically flow. When you deploy a new application, visibility should automatically be there. And so if we provide, this kind of automation interface, you set up a new application, you don't even have to come to the UI. It's just there. You roll out a new, like, voice over IP server, automatically all that traffic should go to your quality of service monitoring tool so you understand how it's behaving. And that's something that we've built in and have had very positive response on.
Great. Thank you, Jim and Scott, for answering those questions, and I wanted to thank the audience for joining us today. I know a couple of you had questions that unfortunately we weren't able to get to. I will be sure to pass those on to Jim and Scott. And once again, please do look forward to that email from Enterprise Management Associates tomorrow for the free white paper. Thanks again for joining us, and enjoy the rest of your day.